Hi everyone, this is me Hassan and welcome to my channel Hassan Academy. So today we are going to discuss one particular reaction which is very important. Okay, HBD. What is the full form? Hoffman Bromamide degradation. Bromamide degradation. Okay. Many one I have seen student remembering it. HBD, happy birthday reaction. Okay. As long you can remember, no matter whatever the way, it is absolutely okay. HBD means happy birthday or Hoffman Bromamide, doesn't matter. What is happened there, that is important, and how you will tackle those questions, that is important. Okay, so here what is going to happen, you are going to get one amide and here you will get some reagent Br2 plus KOH or NaOH. In NCERT it is clearly written 4 mole of NaOH. Even KOH is taking, no problem, you will get amide. Okay, so first of all, amide is going to convert it to amine. What is amide? RC11O NH2. Yes, and this one you will get in the form of NH2, RNH2, amine. So primary amide is going to convert it to primary amide, that you have to remember. And once amide is going to convert it to amide, you can see this carbon is gone. One carbon is gone means this way you make short notes. One carbon is gone means what? It is a step down reaction. Step down reaction. Okay, then from same molecule you are going to get amine, so it is a intramolecular rearrangement. Intramolecular rearrangement. And one more thing, in the mechanism, now I am not going to show. In the mechanism I will show you that how they are, this R group in between only they will transfer from here to here. R group is attached with this carbon, but it will from here it will migrate to nitrogen, this intramolecular nitrogen, and this step is the rate determining step. So okay, so that you can write alkyl migration. It may be aryl also, no problem. Alkyl migration or group migration. Okay, group migration is the RDS. So that thing you have to remember. At last, amine, primary amide. So secondary or tertiary amide doesn't give this reaction. Does not give this reaction. And at last, this one you cannot see here, but I am telling now, and when question that related will come, that you have to understand that time, that retention of configuration happen. Retention of configuration take place. Retention of configuration take place. Okay, so this thing you have to write whenever you are going to learn any reaction. What are the important things are there, you have to write in one side, in that page only, don't go another page, anything, here only you just write aside, and then you go for mechanism. Some mechanism really not required for your level, but some mechanism really important, and for JEE advanced you go through mechanism. Okay, whatever your teacher giving, go through that mechanism. Now I will give this mechanism. You can see here in NCERT amine chapter. In amine chapter I can show you. Yes, this one you can see here. Can you see? Yes, this one HBD. I have also written HBD, Hoffman Bromamide degradation. You can see here 4 mole of NaOH they have written. Here you see something, it's written mechanism important. Okay, for JEE people this mechanism very important. For NEET also you can go through mechanism easy only, nothing is there. Okay, few things is coming in between mechanism, so any moment they can make twist for JEE people, especially for JEE advanced. So it is better you should know mechanism in details. You take the screenshot, then I will go for mechanism. Okay, let's start mechanism. Now I grab this one. Okay. First of all, let's take this one RC11O and H and Br2 plus 4 KOH, R and H2. CO2, K2C, CO3, all these byproduct I am not going to write. Whether really 4 KOH is required or not, that also we will see. Okay, first OH minus will come from that KOH and it will take one proton. So what you will get, RC11O and negative charge, one H is still there. Okay, Now definitely it is going to participate in resonance, that is I am not going to show. It will come here and it will go there, then again once it will come back, now it is going to attack the Br group. Okay, Br it is going to attack and Br minus will go. So what you will get, R C double bond O and Br and H. Okay, so after that again OH minus, this is the second OH minus coming. Okay, second OH I am showing here only, second OH minus coming and it is taking this proton. So what I will get, R C double bond O and negative charge Br. Okay, now you see, now twist will happen, and this is very important. From this negative charge, instead of it is attacking another bromine, it will come to here. Once it will come to here, this R minus is going to transfer to here, and same time Br minus will leave. Okay, and this is RTS. This is RTS. Okay, migration. This migration is the RTS, and what you are going to get, R N C double bond C double bond O. What is this? This is alkyl isocyanate. Alkyl isocyanate. Isocyanate. Okay, not cyanide. Cyanate. Cyanide means NC. This is NC double bond O. Okay, alkyl isocyanate. And whenever you are getting this term, particular term, alkyl isocyanate, this is coming in so many other mechanisms. Okay, so those things also you have to remember. Okay, and same time this particular term is very important because there is a particular molecule that is called MIC. Okay, methyl isocyanate, CH3 and double bond C double bond O. This compound is very important for general knowledge also, because this is responsible for Bhopal tragedy, Bhopal gas tragedy. Okay, in Bhopal gas tragedy many people died because of this particular gas. Anyway, you just write for extra information this one. Now see how many OH is utilized, 1 2 OH is gone. Now you see next what will happen. Now this carbon you have to see very carefully. This carbon, even though it is in between nitrogen and oxygen and it is octet also fulfill everything, okay, but you have to notice that this nitrogen and this oxygen both is more electronegative than carbon. Okay, same like C double bond O, CO2 also, this carbon is octet fulfilled, but it is participating in many time reaction because this carbon is electron deficient, and here also in electron deficient because one is nitrogen, another oxygen, both is more electronegative than carbon. So definitely they are pulling electron towards themselves, and this carbon is electron deficient, and due to that another OH will attack this particular carbon. Okay, now you can understand this carbon will get attacked by another OH. Once it will get attacked, carbon cannot make 5 bond definitely, so nitrogen will pull one electron towards itself like this, and you will get here R N minus C OH double bond O. Okay, up to here you got already. Now you have to see here very carefully. Now some books they are giving this proton is directly coming from here to here. If it is directly proton is coming from here to directly transfer to nitrogen, then O minus will form. At this time even 3 KOH is okay, you can get the same product. And some books are showing like another OH minus, another OH not another OH minus from proton, sorry, not from proton, from water, sorry, from water, because this OH minus is taking this proton, right? So they are getting water. Okay, from that water one proton will come, and that will take here, and next time what will happen, this particular acidic proton will be taken by the base KOH. Okay, the base will come here and they will take this particular proton. Once it is gone, what is left here now? You can see R N H and C O minus double bond O. Now this one will come this side and this one will come to here. What you are getting, R N H, negative charge again from water, it will get another proton, R NH2 plus CO2. Okay, hope you got it. So this is the case. Suppose if you directly consider that this proton is coming here, at that time you can consider even 3 mole of KOH is enough. But if you trying to show that this particular acid group, since base is there, base is going to take this proton, now 4 mole of KOH is required. Here is one, where is one? Here is one, Where is another one? Here is another one, 2. This is 3, and this is 4. Hope you got it. So this is the way that what is happening, everything. Okay, and this step is important. Okay, this alkyl isocyanate production is important. Okay, take this screenshot, then I will give some example. Okay, video is getting lengthy, no problem, but I will give some example now only. Suppose very simple one example I have given this one. What will be the product? Everyone do by yourself, but I am writing the product. Okay. Then next I am giving one C11O NH2. Suppose I have given here R group, I have given here some R dash, here hydrogen, okay, and I have given the same reagent. Now here NH2 will come in this, okay, and here R dash H. Okay, so nothing is going to change. That is what it is saying, that retention of configuration. Okay, same thing will happen. Another example related to retention of configuration, let's give C11O NH2. So now the problem is, if you are not sure that this particular Hoffman Bromamide degradation is going to retain its configuration, if you are not sure, in exam they will give 4 different options. Out of that, one will be above, one will be below, and they may write that both A and B. So if you are not sure anything, that then time you will get confused that maybe carbocation produced somewhere if you don't know mechanism, and due to that carbocation some are above the plane, some are below the plane, both can happen. Okay, so it is very important that you know particularly that this particular reaction is going to retain its configuration. So what will be the product? In below only NH2. Yes, at last you may get this type of compound also, C11O NH2, but N is isotope they have used like N15 and Br2 plus KOH. Even though it is isotope, you should know that the same molecule, it is intramolecular, so same molecule here will come, sorry, benzene not exactly NH2 15. Okay, same NH2 will come, same nitrogen will come here. Okay, hope you got it. One last reaction I am going to give you to try to solve it. Amide, and here ketone, and I am giving Br2 plus 4 mole of KOH. What is the product? Everyone try to do yourself. Okay, pause the video and try to find out this answer you are getting or not. Okay, here suppose I have given X plus Y. What is X? What is Y? You have to find out. This is little bit a good question for the advanced kind of. Now you have to understand that here amide is there, and definitely it is going to show the Hoffman bromamide, so it will be going to convert it to NH2. Yes, and one thing you have to understand, methyl ketone is there. Since methyl ketone and bromine plus KOH is given, so it can show the bromoform reaction also, haloform reaction. It can show bromoform reaction. In bromoform reaction, what will happen? It will convert it to K plus plus. This can be your X, and plus CHBr3. This can be your Y. Hope you understand. And in same reaction they can do lot of things. Suppose they have given here below the plane. Okay, then now they have the opportunity to make lot of options. Yes, somewhere they will give this one above the NH2, below NH2. So everything you should know very crystal clear. Then it will be very good for you. Hope you understand. I just try to explain. Suddenly I realized I should explain this one. I am explaining it, and slowly I will show some other reaction also, and you do share with your friends so that I can make more and more video. Thank you for watching.